Welcome viewers. In this video, I am going to discuss about the interference of light. Before going into the definition of what interference is, firstly I would like to tell about the principle of superposition. When two or more light waves travel in a medium simultaneously at a time, such that the waves act on a particle simultaneously, then the resultant disturbance on that particle at a particular time is given by the principle of superposition. Suppose this is a particle. On this, two waves are acting at a time such that y1 is the disturbance on this particle due to the wave 1 and y2 is the disturbance on the same particle at the same time due to the wave 2, but due to in the absence of the first wave, then the resultant when the two waves are acting at a particular time is given by the principle of superposition by the vector sum of the two disturbances, that is y1. The plus sign holds when the two waves act in the same direction, that is the disturbances are in the same direction, and when the disturbances are in the opposite directions, then we have the negative sign. Now when light waves falls on the particle at a particular time, now then by the principle of superposition we can observe the variation of intensity in the resultant observed wave spectrum, and this leads to the phenomenon called interference of light. Young observed the interference of light using pinhole. He passed sunlight through the pinhole. Suppose this is a pinhole. Sunlight is made to fall on this hole. The light emitting from this hole is made to fall on a distant which is far away from this and equidistant. These two are equidistant, that is the distance this and this are equal. Then these two sources will act as virtual coherent source. This light coming from this source will interfere with each other, and if their resultant is observed on a screen, then we can observe interference pattern here. Now for Young's experiment he used sunlight, so instead of observing variation of intensity, what he observed is of course variation of intensity along with some color fringes, that is the center both sides he observed some colored fringes. So this was the first demonstration of interference of light, and later if we use monochromatic light, that is having only one frequency, then the variation we will get alternate dark and bright bands. Now we will study the analytical treatment of the interference of light. We are considering that light waves, monochromatic light waves are falling, and this is again the similar kinds of pinhole. They are allowed to fall on second slots of pinhole, it is S1 and S2, which are acting as virtual coherent source. This is the screen. Let us consider a point P on the screen. The displacement of a particle here at a particular point due to the light waves coming from this slit S1 is given by Y1, and its expression is supposed to be A1 sine omega t, and the displacement at P due to the light waves coming from slit S2 is given by Y2 equal to A2 sine omega t plus delta, where delta is the constant phase difference between the two waves which are interfering. Omega is the frequency of the light which is made to fall here. A1 and A2 are the amplitudes of the two light waves. Now, by the principle of superposition, we can get the resultant displacement here given by simple algebraic relations. We can get if we consider this part to be equal to r cos theta and this part equal to r sin theta, we can get r sin cos theta sin omega t, r sin theta cos omega t, which is equal to r sin of omega t plus theta. R square is obtained as r square is equal to this square, it is a1 plus a2 cos delta square plus that is equal to a1 square plus a2 square cos square delta plus sin square delta is equal to 1, that is a2 square plus 2a1 a2 cos delta. So we get r square is equal to this. So what is r square? R square is the amplitude of the resultant wave. So the intensity of the resultant wave, which is proportional to this, is defined by this term. So we can say that maximum intensity will be obtained when this is maximum, which is obtained when cos delta I intensity is represented as I will be maximum when cos delta is equal to plus 1. That is delta equal to what? Delta equal to 2m pi. where m is equal to 0, 1, 2, this. This is what? This is the phase difference between the two particles, as I have already stated in the beginning. Now, what will be the path difference? Path difference and phase difference is having a relation between them. Phase difference is suppose delta and path difference is x, then the relation between these two is given by delta is equal to 2 pi x by lambda, where lambda is the wavelength of the wave. Now here, if delta is this, then the path difference is obtained as m lambda by 2, where m is equal to 0, 1, 2, this. So if these conditions are satisfied, what we are getting? We are getting the maximum intensity. That is, I max will be equal to, this part is 1, so a1 square plus a2 square plus 2a1 a2, this is equal to a1 plus a2 whole square. Thus we get the resultant intensity for maximum when the two waves overlap in phase, that is cos delta equal to 1. We get the resultant intensity I is greater than the intensity of the individual waves. That is, this is the intensity of the first one, this is the intensity of the second one. So this is greater, the intensity I max here is greater than this part. Now let us go for the minimum intensity. I min. So what will be the condition? This should be equal to -1, then you will get the minimum intensity, that is cos delta is equal to -1, and this condition is satisfied when delta is equal to odd multiple, that is 2m plus 1 pi, where m is equal to again 0, 1, 2. So what will be the phase difference? This is the phase difference. So what will be the path difference? Path difference will be then equal to 2m plus 1 lambda by. Now I mean will be equal to what? a1 square plus a2 square minus of 2a1 a2, that is equal to a1 minus a2 whole square. Again we see that the minimum intensity point or the minimum intensity is, that is I mean, is less than what? The sum of the individual intensity, that is a1 square plus a2 square. And if the two amplitudes, the amplitude of the two waves coming are equal, then what will be I mean? I mean will be equal to 0. Okay, a1 is equal to a2, and here I max will be equal to this, that is 2a1 square, or 2 we can write a, that is equal to 4a square. So when the two amplitudes are equal, we get the maximum intensity as 4a square and the minimum intensity as 0. This point where we get the maximum intensity, this point is called the constructive interference point. And this point is called the destructive interference